Hello everybody, this is B.S. Satyadev, Assistant Professor, Computer Science and Engineering Department. Today I'm starting a new series of presentations which is on database management system. So before going to explain what database management system, I introduce you about the concepts and various definitions, stuff like that. I would like to emphasize that this topic, database management system, is one of the core topics that a computer science student is supposed to know and learn. So basically, over a period of time, some of the subjects, become obsolete and go away, and in place of them, new subjects might come in. But as database management system is a core subject similar to operating system or data structures or networking, any computer science student should have the knowledge on this subject. Now, saying that, so the concepts that are going to be learned here are going to be directly used when somebody from CSC or become a programmer or a developer or a QA or anybody. So this is very, very important to learn to understand the concepts of data management system. Now, before going to introduce the data management system, one more thing I want to emphasize is that this database management system is not, a subject like it's not done created in one day or one year or 10 years. It has been progressing a lot. There are going to be changes. There are changes that happened in the past. There are changes happening now. There are going to be changes going to be in the future. However, the overall concept of the database system still remains the same. So that is the reason it's very, very important. Now, let's get into the subject. Now, the name says database management system. We'll drill down into each one of them, but by looking at the name, somebody can guess it is about data. Now, one of the misnomers that computer science students has, maybe first year, second year, something like that. So is the most important part of learning computer science engineering is the programming. So let me be honest with you. Yes, programming is very, very important for a developer. But when it comes to business organizations and people who use the programs or the software is not the top priority one. It might be surprising to you, but that is true. Software is not the highest priority one. It is the second priority. But the first priority is the data. Because unless you store data or you have data, the software is useless. The entire software system, especially the commercial software or business which are also known as business softwares, are running around data only. So data is the utmost important piece of information that needs to be focused. That's why this subject database management system deals with data. Now let's get into the presentation. Okay, so what are the topics we are going to learn today? I'm going to start with data, some definitions and other concepts. Then I'm going to talk about file processing system, which is also a data processing system, but it's a bit of old way of doing things. And then talk about issues with file processing system. Then we'll go to database management system, which is the main topic. I'll just briefly define what it is and all the other pieces that are involved in database management system. Then give a comparison about FPS and DBMS. And then we will see at a high level what's going to be there, what we have learned. Right? That's pretty much the plan for this presentation. Now let's go and get into the data part of it. Now we'll see some definitions and concepts of data. Now what is data? It's a simple question. Many people think that they know the answer, but in reality, data is nothing but a fact. A fact that we can see or perceive is called data. So as per the textbook definition, data is a collection of raw facts, figures, that means pictures or something like human being details and stuff like that, caricatures and all that stuff, and observations. So what we observe, all this comes under data. Now, what kind of forms the data can take? If you ask that question, a data can be numbers, a data can be text, a data can be pictures like images, data can be an audio. Audio is also data because let's say I'm talking now, whatever I'm talking is a fact that I learned from a book, right? So it is a fact that you can also hear. There is a file that is going to be created. So you can see that, yeah, this is the file which contains what Mr. Satyadev talked about database system. So that's pretty much a data. Similarly, videos, all these things, and there are many, all these things that we can see and perceive, which actually talks about facts, are called data. Now, when I say data, we have seen different examples in the previous slide, but how do we classify data at a high level? If you look at that, there are three ways we can classify data: structured data, semi-structured data, and unstructured data. So what is structured data? Structured data is a data collected and follows a predefined format, strict predefined format. It's not like you can change it whenever you want. So you define a structure for that, you define a format for that, and you put the data in that format. You collect the data, or whatever data you get, you put the data in that format. That's called the structured data. Basically tables, with rows and columns, that's we normally consider as structured data. If you want to connect structured data with real world examples like financial data, year-wise financial data, employee details, flight schedules, library catalog, all these comes under structured data. Now, to take up an example, if you must have seen the flight schedule, right? So the flight number, from destination, time of starting or boarding time, all these things are there in a table-like format. So, and that table contains information of several flights. Each row is for one flight, right? So flight is boarding, you see the status also of the flight, right? So the table, whatever it is, you see the data in the table is the structured data. Now let's go to the second classification, which is semi-structured data. Semi-structured data, unlike structured data, has some structure, but it is not so rigid compared to structured data. So if you look at an example like HTML files, JSON files, XML files, configuration files, so these are all come under semi-structured data. Why they come under semi-structured? Let's take the example of HTML. HTML, you have a header, then you have a body, then you have footer and all these things. But you can have some tables in HTML page, you may not have. You can have some anchors, you may not have anchors. So certain things you can have, certain things you can optionally omit based on your requirement. So there is a structure it defined, but that structure is a loosely defined structure. You don't need to follow exactly, you need to fill up everything in there. Whereas in structured, you have a row, a set of columns or with boxes. You have to fill something. If you don't have anything, you say not available, right? Not available. Something like that you have to fill in. Whereas semi-structured, when certain things are not available, you can just omit them, right? So that's why it is flexible, but it does have some structure similar to structured data, but it is flexible. Now, if you take unstructured data, any data which doesn't fall under structured and semi-structured, unstructured, it's just available in raw format, like photos. You see bunch of pictures. Each picture is different. Each picture size is different. Each picture content is different, right? So, you have 10 pictures, all 10 pictures, unless they are like copies of each of them, they are all different, right? Even if they are copy, but each one has got its own file. So you can't say these two are same, right? So they are two different things, and they may be located in two different locations in the hard disk, right? So pictures, audio files, and again you take documents. So what you can type in a Word document, it's up to you. You can type anything. The format, you can decide if you want to go with the format, and again you can change it. So there is no rule or anything like that unless it is really you have to follow. Now, but one thing I want to say here, in certain places or certain type of documents, they say, okay, put everything in this format. For example, design documents. You are designing a software. The software design document should contain, all the nomenclature, all that stuff, right? So low-level, high-level design, low-level design, UML diagrams. There is some format. You fill in those things. So you don't want to violate that format, right? So in a way, it could come under semi-structured, but basically, other than those kind of things, any text file or document file or PPT file that you fill in with your own information, you create your own things. So that's called unstructured data, right? So basically, that's about the classification of data. Now, in database management system, in this subject that we are going through, we mostly focus on structured data, not on semi-structured or unstructured data, which actually advanced to DBMS, so which we may have to learn in a different series. So unless I specify that yes, this is not structured, this is semi-structured or unstructured, whatever we are learning is all about structured data and its concepts and stuff like that, right? So that's pretty much this slide talks about. Whatever I talked about, same thing I presented in a visual format. So structured data, characteristics, highly organized with a predefined schema. Schema is like a format. Schema is nothing but a format, right? So predictable and easily searchable, all this stuff, right? So for example, customer table with name, email, ID, that's structured data. Semi-structured data, flexible schema format without a formal table structure, tags, keys, use keys and all that stuff, right? So JSON, configuration file, Java properties file, all these comes under semi-structured data. Unstructured data, like no predefined format, irregular data types and massive in volume, high data diversity, media files, photos, posts, logs, messages, Google messages, charts, all those things, with no concrete structure or anything is called the unstructured data. That's pretty much the pictorial representation. Now there is one more thing which I'm going to talk about. Some of the students of computer science initially they might get confused with data classification and data types. Data classification is about at a high level, how do you put data into various buckets, the three buckets like structured, semi-structured, unstructured. Data type is something like a very low level thing. Data type is like, okay, whether it is structured or semi-structured, unstructured, what kind of data you are storing, that's what data type is. Data type is a classification that specifies what kind of value a column or an attribute, we'll talk about columns attribute later, but can hold something like that. So again, I'm not going to go deep into this because we're going to learn again later about data types that are there. But just to distinguish, when data classification is different, data types are different. That's pretty much what I want to now. So we are slowly going towards the understanding about database management system. We learned about data. Now let's talk about data management. So what is meant by data management? So data management is nothing but defining the structure of the data. Again, remember, we are only focusing on structured data here in this presentation series mostly, right? So that's why defining the structure of data is part of data management. The second thing is providing a mechanism to store, access, change or remove or delete, right? Is also called data management. So for example, you let's say you are storing, you are planning to store some roll numbers, right? So on a sheet of paper. So whoever has some juice for some library or whatever it is, you write all these numbers on a piece of paper. That is called storing. Now you want to, somebody has come, that roll number 26 has come. You check the paper, okay, 26. So that's called accessing that. Okay, 26 juice are there. Okay, he paid the juice. Now you say you tick it off. So or he paid only half of that. You write that only paid out of 100 rupees only 50 rupees. So that's changing. Now roll number 86 has come. He said, look, I'm paying all the juice. Okay, done. So you have to remove that guy. So strike it off. That's removing. So basically a plan or a mechanism or a way of managing, way of storing, accessing and changing or removing data is called the data management. So basically data management means two things. One is defining a proper structure for the data. So in this previous example, like roll number, due, status. You have defined the roll number 26. That is one column. Amount, second column. What is the status? Paid, unpaid, partially paid. That's pretty much the structure. Now whenever somebody comes in, you modify it. That's called changing. You adding all the people into this is storing. Finding somebody, like somebody has come, you have to find that record, is called accessing. And somebody has paid, you don't want them to be in the record, remove it, is called the removing. So that's pretty much data management. So we talked about data management. Now what kind of data we want to manage? That's a very, very important question. Do you want to store, manage all data? For example, I have, like, you know, um, if, for example, I have like my password, right? So I have my password. Now, let's say there are three passwords I use to get into the system. Now, is it really required to manage that passwords? We need a way of managing that. May not be necessary, because just three passwords I can remember, right? So actually passwords we should not be writing on anywhere and managing just simply in a simple way. So there should be some characteristics for the data to be managed. Not all data needs to be managed. For example, you are listening, for example, you got some information from somebody, like temporary information, like these are the three numbers who came late for the um, class, so good, don't give attendance, something like that, right? So in that context, you just you write it on a paper and you just don't give the attendance, right? Or give attendance, whatever it is. But you don't need to create a big management system or a way of doing things. You just need simple way of doing things. So basically, in order to manage data should have certain characteristics. So what are those characteristics? So basically, data stored and managed should have these characteristics, like highly valuable, relatively large, multi-user access, and concurrent access. So these are the um, four major aspects. If data has, then we want to manage the data. We talked about managing data earlier, right? So we want to manage that only when um, these four major things are available. Now, highly valuable means what? So the data that we get is very, very important data, and it needs to be kept in a proper way. For example, when students join a college, so you want to take all their names, phone numbers, their addresses, their father's name, phone numbers, their intermarks or whatever it is, the ranks. All this information is a very, very important information. This is like, you can't just write them on a paper and then throw it away, and again you need to flounder around that paper and figure out, right? So you need to, that's a very valuable data, right? So let's say you want to send a message to their parent, or you want to call a student, you need that data to be stored somewhere. So data should be the first thing. Primary criteria for a data to be managed is it should be a valuable data. Also, the second criteria is a relatively large data. You have only three students. I mean, do you really need a system or a big way of doing, managing that? You don't need it, right? So unless you have huge amount of data, for example, you take our college, there are 10,000 students, so that's a huge data, right? So if you want to collect the data, student name, address, and all these things, you need a system to manage, right? That's called that's the size of the data. Small data cannot be managed manually, so can be managed manually. Managed data must be large enough to warrant a system. That's pretty much what relatively large data is. Multi-user access. Now this is an important thing, that is a derived thing from the highly valuable data. Now, let's assume that there is a data for the student information is stored somewhere. We'll talk about how it is stored, where it is stored, all that stuff little later. It is being managed, right? Now, since it is being managed, there is somebody who is managing it. Let's say some human being. Now, it is highly possible that many people will talk to that guy and get it. For example, so computer science department go to that. Okay, maybe a teacher from a computer science department goes to that managing person, data management person, say, hey, these three roll numbers, I want to get their phone numbers. Can you give me the phone numbers? So again, civil engineering, maybe. So when data is there, which is like highly valuable and relatively large, and it is being managed, multiple people definitely will access that. That's called the multi-user access. So this is one of the characteristics of data that needs to be managed. So valuable data has many stakeholders requiring simultaneous access by multiple users. Simultaneous, I'll talk about this next one, concurrent access. So concurrent access means what? High chance of multiple users accessing the same data at the same time, concurrency must be handled. So we can take, normal student case, you may not need concurrent access, but think about banking applications. Say, for example, you have a business account where several people are adding money. For example, Amazon bank account, right? So for example, you are paying to Amazon. So as we keep paying to Amazon, several people are keep paying to Amazon, and again, Amazon might be refunding people back to their credit cards because of some reasons. So all this happening like in high frequency. So that means several people will hit the same record at the same time, for example. That could be a high possibility, right? So concurrent access means multiple people accessing the same data location is the concurrent access. So highly valuable data, when it is relatively large and used by multiple users, it is bound to have concurrent access at some point of time. May not be always, but definitely yes, there is going to be there, right? So that's pretty much about characteristic data. Okay, great. So let's go to the second module of this presentation, file processing system. Now, as the data management is a really important piece, even in 1960s and 50s also, people started creating systems to manage the data. The way they used to do that is using files. Right, so even after the advent of computers back in 80s and early 90s, I wouldn't call back in early 80s and mid 80s, file processing system, especially using computers, was very prevalent and much was in use. So data management used to be done using files. Now, what is file processing system? What are files? Let's just go into the details. Now, what is a data file? A file, it could be a text file or a binary file, used to store, access, change and remove structured or semi-structured. I mean, let's keep semi-structured aside for time being. Structured data is called a data file. This is a traditional method of storing data before database management system gives rise to birth. So basically, data file is nothing but a file, could be text or binary, which allows you to store, access, change and remove structured data. So they're basically managing the data. That is called a data file. Now, what is FPS? FPS means file processing system. FPS performs data management using computer programs and data files. So basically, when it comes to 80s, like I said, early 80s and 70s, mid to late 70s and early 80s, people used to do data management through files. So for example, let's take the student information example. When some students come in, there is a screen where they enter the information. Okay, student comes into the counter. Okay, what is your name? What is your rank? They tell the rank. What is your mobile number? Father's date, address. All these things stored and say save. They click a button called save. Then the data is stored into a place called file. So first student is there. Then another student comes in. Again, enter all the details on a screen, on a computer screen. You type all the details. Again, it's going to be stored in the same file. Now this screen, user interface screen, is the program that gets the data. That's a program that takes the input data. Now what the program does is it collects the data. Once it is collected, it will be storing that into a file. Well, how do you want to store text or binary? Depends upon that. If it is information which it's okay to somebody can see it, nothing wrong, it's okay to store in text. No, you don't want somebody to store. As soon as you open the file, you can't figure out, you don't want to figure out what's there in that, then you go for binary files, right? So basically that's pretty much people used to do. Student information, I think it's okay to store in a text files, right? So that's pretty much what it is. So each file processing system used to maintain its own data file. So for example, student case, right? You get all the student information stored in data file. So what the department where they collect the student information, what they do is they ask the programmers to write some programs to get the data and put it into the files. So their job is to collect the data and store. All good, right? So that's done. So data is accessed through application, store access means like stored in the. Now, this data is there in the files. Now let's say principals or some head of the department, whoever it is, right? They want to understand, get the list of all the students whose rank is between 1 and 1000 or maybe 500, for example. The management wants to understand rank 1 to 500, how many students are there in the college who have joined the college. Now, the program that is written by the storage people, it's only for storing data. They don't have the program to filter that out and give it. So the department attached to the management office, they may have to write their own programs to read those files and collect the information that management wants it. Like first rank number 1 to 500, give me the list of all the students. So they read the data from the file and they filter out the data according to the condition they want. Now later management says, okay, 500 we didn't get too many, let's extend this to 1000. Then they have to write either another program or they have to change the program to get the 1000 records. Now they said one more requirement. People living in this pin code, I want to know how many students are living in the pin code. Then you have to write another program. So basically each problem context gets its own separate file processing system. So now once the data is there, now you want to assign roll numbers to them. So people, the department, the operations department, they take the student data. When you collect the student data, there is no roll number because it's just the students have come and registered their details like their name, mobile number, address, their rank, all that stuff, right? So they don't have roll number. But the operations department wants to create roll number. So they take this data and they are creating roll numbers for them. So they have to write their own programs and they have to have their own file processing system. That's pretty much how the file processing system used to work. Now, FPS characters, file processing system characters, are data stored in flat files, which we have discussed, text or binary, separate files for separate applications. Now, like I said, the front-end people who get the data from students, collect the data and store, they're only concerned about students, their mobile numbers, rank numbers, details, father's detail, address, location, all that stuff, right? They're only concerned. Now, people from the operations department, they are more concerned about giving a roll number and putting them in sections, right? So they do that. Once they have done that, now the examination departments are more concerned about marks, right? So they are providing marks for each and every mid exams or end exams or all that stuff, right? So each department has got their own requirements. So what they do is they might copy this data and they modify it, the right programs to modify according to their things and get with that. That's how that used to happen. So each department has their own data, almost same data with different things. The collection department, the front-end department only has got student information. The operations department, student information, roll number, fees, they have paid fees and all that details. The examination department has got all these details along with, they don't need fees details, right? They only need examination marks and all these things, right? So they might need, but so everybody maintains their own copy of the original data. So that's one of the characteristics of file processing system. So limited sharing of files across multiple file processing system. So each department has got their own file processing system on the same set of data or almost same set of data. So the programs that are written for those files are tightly coupled with the data that they are handling with. What examination department would do, they add more columns, more data items to the data. So that means, it has the original data like student information, apart from it will have the exam details also. That's how, the FPS system is to work, right? So obviously you can guess that there are problems with the file processing system. So what are those problems? Let's go through it. So first thing is data redundancy and inconsistency. Exactly like I said earlier, data redundancy means same data stored in multiple files by different programmers. So basically this is pretty much what the redundancy is. So you already have this data. Again, I want to copy this data and work on the copy of it. We are making data redundant, right? So, but I need to do that because, these guys might change it. I don't want those changes, all this stuff, right? So that is one issue. Inconsistency, duplication increases storage cost. So basically, yeah, I mean the second problem is like duplication, because I have this file, I'm copying this file to another. So you are holding the same data in two different places with small changes, right? So that's a duplication effort, which takes like hard disk space, storage and management and all these things, right? So duplication, storage card. Inconsistency when one copy is updated but others are not. For example, student mobile number is changed. The front desk people have that change done. They have to give this information to the other departments. It could take some time, right? So meanwhile, the other departments are dealing with the old phone number. So unless they get the data periodically, immediately is good. At least periodically, they have inconsistent data. So the phone number in actual phone number that's got by operation team, front end team, people who collect the information, is different with the operation team, different with the examination branch. It could be like inconsistent across all the departments. The main problem for this is there is no central place that everybody is accessing the data. So in file processing system, data is accessed independently. Everybody has their own set of data. There is no central place where data is being maintained. That is one problem with the file processing system. Second problem is difficulty in accessing data. Like I said, easy example. Management wants to know rank number 1 to 100 today, 1 to 500 today. Tomorrow they say they want to get all the people who are NRIs, right? So then again you have to write another program. So like I said, difficulty in accessing data. Programs written only for predefined tasks. So yes, data has got all those things, but you need to write programs to get the data, right? So that means each time programmer needs to be involved. So programmer has to analyze this, spend some time, design this, code this, bug fixing. It's a long process. Software development is a long process. So it takes time, a lot of time. So again, manually, you can say Control F and you go to open the file. Assume that it's a text file, Control F. You can do that, but it's not that easy for everything, right? So you want to have multiple people do that. So it takes it like a lot of effort, right? That's one of the main problem. This difficulty in accessing data is happening because there is no standard way of querying or retrieving the data. That means so basically what we are doing is, from this piece of information, I want this and this as conditions and give me the data. That's pretty much what. For example, you take the case of give me, so student data is there in a file, text file, right? Student name, their phone number, their rank, their address, pin code, father's, all these details are there in the text file. Let us assume that is there. Now what you need to do is you make that into several pieces. Name is one piece, rank is another piece, phone number is another piece, address is like that. You divide them into multiple pieces, right? So for rank, what you need to do is rank 1 to 1000, for example, right? So you need to focus on rank portion of the each and every data of the each and every student, right? So basically, even though for rank thing, for example, you want to understand who are there in the same pin code. Now you have to focus on the pin code. So basically, the process is same, searching process is same, but the problem is we are searching on different aspects of the data. So searching process is same, but we are searching at different locations, right? That's pretty much what the root cause of this file processing system. So that's why you have to write several programs for these things. So that's it. Now data isolation. This is another aspects. Data stored in different files and format across department. Yeah, this is another problem. This is big problem. So front end department who collects the student information, they store in text format. Now exam department, they think that okay, student marks are can't be seen by everybody, they are like private things. So let's read the file, get the data, copy it, but while copying, don't copy in text file, let's store it in binary files. So and also add this column name, phone number is not correct, let's make it as mobile number or a contact number. they could do that. They change the column name. Now, if you look at the front end people and the examination department, they have same data with two different column names, right? Um, so the format is changed, kind of changed, even though the data is kind of same. So basically, in that kind of situations, if front end people wants to, if you have a look at the examination department, they don't have any clue. So retrieving related info becomes difficult. Again, for every file structure, you have to one set of programs. If somebody changes the column name, again you have to change the. So basically, the main problem with data isolation is that scattered and unorganized data storage. So data is not organized. You just store it as per your wish, right? So there is no control over how you want to, okay, this is the name should be mobile number. If it cannot as a contact number, it cannot be phone number or mobile number. Let's say you fix it. So then it's good, right? Everybody has same format, right? So, but that thing is not there with the file processing system. That is another problem. Fourth problem is integrity problem. So business rules, like you want to incorporate business rules, that yes, you can do that using writing programs, but every time you have to if there is a new business rule, you have to write code for doing that, and again if the rule changes, again you have to update. But the thing is, programming is error prone, right? You write a program, you might end up breaking previous rule and stuff like that. So you have to write test cases and all these things in order to make sure that it is work correctly. So with file processing system, there is integrity problems where the constraints are not completely managed, properly managed, and they are not centrally managed. That's pretty much what causing the integrity problem. That's what pretty much what it is. So other than that, there are other problems like atomicity problems, concurrent access anomalies, security problems. All these problems are there. So atomicity problems, say for example, like system failures can lead to partial operations. So for example, A is sending from account A, the amount is being transferred to B. So what should happen is it should be deducted at A, it should be added to B. It should be added to B, right? So for example, after deducting money from A, system crashed, your database system crashed, then the money is gone from A, it's not deposited into B. So that's a problem. That problem is atomic problem, because even though you are doing two things here, taking money from A and putting into B, like two things you are doing, but in fact the entire set of two things is one atomic thing, one single thing. So you have to consider that if one fails, the entire thing fails, right? So you subtracted from system fails, then it should be added back to A, right? So that's how you have to manage that. So that is atomicity problem. Concurrent access anomalies, the same kind of things. Let's say I have 100 rupees in my account. Two people are concurrently adding 10 rupees and 20 rupees. Now, so the system, what it does is, okay, 100 is there. Mr. A adds 10 rupees. So what A does is he reads 100 and add 10 to 100. So it becomes 110. Now let's say both of them come at the same time. Both of them read 100. So then A adds 10, B adds 20. Now let's say B wrote that information first into the file. So it becomes 120. Now on top of that, A did that. So A thinks that 100 is there. So it will become 110. Now the actual value you can see is 110 only. If B, similarly, if A does first and B second, then you will see 120. But in fact, it should be 130, right? So concurrent access anomalies are there like that. And multiple users are hacking. So we need to have a locking mechanism and stuff like that. So you can't have multiple things on the same data, right? So that's pretty much what problems you have to manage with the FPS. Yeah, FPS has mechanism to concurrent, but it's very you have to write programs that it's not like foolproof thing or anything like that. Another thing is security problems. This is not a small problem. Actually, different users should access only relevant data. Now, even if it is text file or binary file, once you get the data, if you know what is the format of it, you can always decipher that. It could be some sensitive information of the students, health issues and all these things. So FPS, once you get access to data, anybody can access the data anytime. So any program can do the same thing, right? So you may have to restrict that access, right? So that's not be easy in FPS. So security issues are also there in FPS. So that's pretty much what the FPS. So by now we understand that file processing system used to work in mid to late 80s and 70s and 80s, but it has got a lot of flaws. Now then the database management system comes in. Again, this is not like started in 80s, it is there long ago, but they have seen FPS problems and database management system comes into picture. The history of database system I'm going to talk in the next one, but today I'm going to introduce these concepts because these are required to understand the history also. So that's pretty much, that's why I'm not talking about history right in this presentation. Now, what is DBMS? So we have seen what is data, what is management. Now we have to understand what is database. Database, two things, right? So how database is related to data, that's one thing. We have seen what is management system. Now we have to see what this system means, right? So file processing system, we know file processing system is nothing but data in text file or binary file format and programs. That's pretty much what it is. That is the file processing system. Here, what is meant by system here? So we have to understand that one also, right? So that's pretty much what it is. Let's jump into the definition of database. A database is an organized and centralized collection of data used to store, access, change and remove data. So basically the main difference between file processing and database is organization. File processing system with data is sparsely placed at different places, whereas in database it is stored at one location, central location, right? So that's pretty much what it is. Unlike FPS, a database provides a single central repository shared across all applications and users. So irrespective of number of applications on that, they all share, get the data, read the data, write the data, modify the data, delete the data at one place. So that's centralization of data, right? Whatever problem FPS has, database doesn't have that. So that's pretty much one definition of database. Now, what is DBMS? We have seen database, we have seen management. We have seen system. System is basically a set of programs and data collecting working together, right? So database management system is an organized and centralized collection of database, and a set of programs to manage the data. So basically similar to FPS, the major difference is organized and centralized collection of data, which is the database. If it is not organized and centralized, it is just file data or file data. If it is organized and centralized, it is database. That's pretty much the database management definition of database system. So a big picture of database management system, you can see that again we are talking about only structured data, right? Focusing more on structured data. You can see tables here. Each table has got like name, like course. Each course has got columns. All these things are there. At one particular point of time, what are the values of those things? For example, you see here the one is like name, student name is like whatever it is, Jalan or 36, all this stuff is there, right? So again, storage and security is also there. Now when it comes to management, this is the data part of it. When it comes to management, what are the things we can do? We can query. Asking is the term that we use in DBMS. Again, DBMS is the short form from database management system. Mostly I use DBMS most of the time, but it is nothing different from database management system. It's a abbreviation for database management system. So we asking in database is also called as querying, query processing, searching, defining organization data, change and all that stuff, removing, updating and all that stuff. Make them secure, like whoever wants to access as much as data, only give them. And also this data this is also another important, backed up and restored. See, data stored in one location, it could after some point of time it could be deleted, right? So because of some reason the machine gets, so periodically you need to take the backup of the data and store somewhere, some other place, which is a different place. Now if something happens to this machine where the database is there, so you restore it back, get it back from the place where you have a copy of it. So that's pretty much what the DBMS does, right? So okay, again we have discussed this, but I'm giving some formal words to this management. The main goal of DBMS, database management system, primary goal is to provide a convenient and efficient way to perform CRUD operations, CRUD operations. It is acronym, which is very popular in DBMS. CRUD means C stands for create. Create structure for the database and storing data comes under create portion of it. Retrieve. Retrieve means extract data from the database, get the data from the database. That is called retrieval. Update. You have data, phone number data is there, you want to update, phone number is changed. Just remove the old number and put another new number. That's pretty much the update. Delete. Somebody is no longer with this system, so you have to delete it. Again, delete, there are two kinds of delete. Temporary delete and permanent delete. Temporary delete only takes it out of the system but keeps in the database. Permanent delete means it's completely gone out of the database, right? So we'll discuss more when you go in more in detail, but there are 4 options. So CRUD means create, retrieve, update and delete. Okay, so we have seen the primary goals, CRUD. Secondary goals are additional goals. I wouldn't call secondary, but additional goals are safety, which is very, very important. Protect data to avoid data loss scenarios. So that's why you take backup and restore. Security, prevent unauthorized access to sensitive data. So basically, you allow password mechanism, user ID password mechanism. Even with that, that is that's roles and responsibilities. So this role only has view access. This role has modify access, but only this data. All this comes under security. So only administrator can see the entire data, not everybody. All these restrictions you can put. That's any additional goal of DBMS. DBMS wants to do that. Consistency, maintain data accuracy in multi-user environment. So make sure that atomicity is maintained, make sure that inconsistency is not there. All these things are called, comes under consistency. Integrity, avoid data corruption and enforce business rules centrally. So you want some certain data to be numbers. You can't let a character to get in there, right? So that's maintaining the data integrity. Similarly, you don't want rank to be negative. Rank of a should be negative, right? So that's an integrity failure. If somebody say minus 26 rank, that doesn't make sense, right? So even fat fingering like minus 26 should not allow, system should not allow, right? So that's integrity. That's pretty much what it is. These are the additional goals of. Now, what are the application area of database DBMS? In fact, when you look at DBMS application areas, I just mentioned few of them, like they are enormous. Everywhere you need DBMS because, as I said, the most important for any business application, commercial, not only business, even scientific also, data is very, very, very important. So, as every system has got data, DBMS can be used in all those places. But I mentioned few of them, like enterprises, like sales, purchases, payments, accounting. And if you take a big company, enterprises, sales department uses the purchase department uses databases, payments, accounting, all these things. Airline, flights, crew scheduling, reservation, ticketing, boarding pass, all these things stored in databases. Education, like we talked about, students, course registration, grades, all this comes under education field. Human resources, employee info, salaries, taxes, benefits, all these addresses, all this comes under human resources. Banking and finance, accounts, loans, credit cards, instruments. I mean, everything is data, right? So every fact is data. So how much he has credit card, what is his credit score, all this comes under. So banking and finance, they do need databases. Internet services, e-commerce, OLTP, OLTP means online transaction processing. Social media, ads, all this comes under, have to be stored in internet services. Manufacturing, supply chain, inventory, order tracking, all this comes under manufacturing. GPS, universities, document storage, I mean, anything to everything. I mean, database, DBM, I just mentioned few of them, but you take any area in this world, you need a database system. Software or non-software is a different issue, but yeah, mostly nowadays with the advent of computers, you need a software related database system to be used. how do you use DBMS? Basically, you have a database management system. We understand what is database management system now. Databases with management, right? That is database management. You have this DBMS. Now, how do you want to use it? There are two modes you can use it. One is OLTP, online transaction processing. It is the main usage. Like, you people come, you store the information, you update the information, you delete the information, all the CRUD operations, right? So basically that's OLTP mode. Another mode is like analytic mode. You have the data and you want to read the data. Mostly it is read-only kind of thing. And you want to analyze the data, existing data. For example, this year you have rank number 1 to 500, there are 10 students. Last year there are only 6 students. Before there are only 4 students. So you can see that there is a trend of 1 to 500, ranks between 1 to 500 is increasing every year. That means the college reputation is going more and more, right? So that's pretty much you can summarize. So how do you get the data? Unless you store the data, you don't get the data, right? So DBMS is used, but in this perspective, you are not modifying or anything. You're not doing any CRUD operations, but you are analyzing the data, right? So of course you are reading it, but after reading it, you are just leaving it out. You are creating information. That's called the information system. So you create some information system out of data. So data, when you analyze it, you get information, right? That's pretty much data and information. So comparison between FPS and DBMS, which we discussed a lot, but storage, when it comes to file processing, flat files, when it comes to DBMS, centralized database, sharing, limited across systems. So each system their own set of data, whereas full multi-app sharing is there in DBMS, like centralized, because it is centralized. Redundancy, high in file management system, file processing system, minimized in central control. Query flexibility, applications, whenever you want a new query or a new program. In DBMS, you may have to write something sometimes, but not that much compared to, you don't need to write a big code, right? So you just need to fill in the blanks kind of thing. Most of the stuff is there, just fill in the blanks. All the program is there, just fill in the blanks kind of thing. So that is query flexibility. Security, scattered. Some people may have security, some they are in FPS, whereas in DBMS, you can have control. Integrity constraints, again, it's on the programmer. It is centralizedly defined, well-defined and managed in the DBMS side. Concurrency, it's difficult. Yes, it is possible to implement in file processing system, but error prone, it depends upon programming, it could cause to the file locking, corrupted files and all that stuff. Whereas DBMS, that problem is not there because set of programs of DBMS are taking care of it, so they know what they are doing. So consistency, difficult to maintain FPS, better consistency. Backup recovery, it is manual in FPS, whereas in built-in support is there. Scalability, it is limited in, scalability means, you want to add more and more data, increase it. Yeah, file processing, you can do that. It is limited to disk. Whereas DBMS, you can do certain things like sharding and all that stuff, which we will discuss later. You can do that scalable more. We'll discuss more later. Data independence, not much. Well, in FPS, it is there. You can independently get the data, process data and all that stuff. So pretty much this is about, again, pictorial representation of same thing, comprehensive comparison of file processing and databases. So I think that's pretty much the introduction to database management system. So what we have learned is about these things, like data is raw facts and classified into structured, semi-structured, unstructured. FPS suffers from redundancy, isolation, integrity and security issues. DBMS provides a centralized, secure, consistent data management layer. DBMS supports CRUD plus safety and ensures safety, security, consistency and integrity. And it can be used in two modes, OLTP, online transaction processing, many users, small apps mode, small operations mode, analytics, few users but large set of data, right? So that's pretty much what it is. So that completes this presentation. We'll have more in this series. We will continue in the next presentation. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.